All right, so which function out of all these functions here has a domain of x greater or equal to negative 11? All right, so all these functions follow the parent function of a square root function. So when we're talking about domain and ranges, as I mentioned before, so the domain is all the values of x or all the values of a function that define it. And what I mean by define it is that means that there is a legitimate value that is mapped to that function, to that value. And the legitimate value has to be a value of the real number line, okay? So in this case here, um, what I'm talking about for different I guess family of functions is that they all have similar domains and ranges. Okay, so for example, like our polynomial functions, all polynomial functions, unless there is um, a a general or a specific set of restrictions set upon them, have a domain and range that is the whole real number set. Right, the whole real number set is the domain and range. In case for our square root function, okay, so the parent function looks like this, where f of x is equal to the square root of x, and you can have different kinds of alterations around that. Its domain is going to be x belongs to all real values except x has to be greater or equal to 0. Okay, and the range of this function is going to be y belongs to all real values, but y has to be greater or equal to 0. Okay, so that's the main and range of the square root function. Okay, and this is because the square root function cannot square root negative numbers. And because of that, there is a restriction upon its domain and range. Okay, so looking at our functions here, we have to evaluate each of the functions and find its domain and range. Okay, and if this domain is similar to this, then we have found our function that has the domain of x is greater or equal to negative 11. Okay, so in all of these functions, we have to ask a question. What values of x will make our square roots be a square root of a negative number? Because what values of x makes it a negative number means that that is a restriction upon its domain. So our first function is y equal to square root of x plus 11 plus 5. Okay, so we don't need to worry about this constant plus 5 out here. We just need to worry about what's inside the brackets. So what is going to make x plus 11 less than or equal to 0? Okay, so the values that are going to make it, sorry, let me make it a what are the values that will make x plus 11 greater than or equal to 0? Well, if we isolate for x, we're going to have x going to be greater or equal to 11, negative 11. So this is our domain right here. By finding this, the values of x that satisfies this inequality, we have found our domain. Therefore, the domain of this is going to be x such that x belongs to all real values, except that x has to be greater or equal to negative 11. Okay. All right. Let's do that for the next couple of functions here. So for b, we have y equals the square root of x minus 11 plus 5. So we ask ourselves the same question again. What values of x will make our square root negative? So what values of x will make this inequality true? Right? So as long as this inequality is true, our function is defined. Right? So if we isolate for x, we have x has to be greater or equal to 11, right? So if x is less than or equal to 11, so let's say x is 10, then this function is going to be a square root of a negative number, and we cannot evaluate it, and it's not defined, at least in the real number sense. Okay, so because of that, our domain here is going to be x is such that x belongs to all real values, but x has to be greater or equal to 11. Okay. So let's quickly evaluate the last two functions here because they're kind of the same. So we have y equals the square root of x plus 5 minus 11, and the other one is going to be y is equal to the square root of x plus 5 plus 11. So you see here, we're not even considering these constants here because they don't really dictate our domain. But our question again is, what values of x are valid for the square root? And so we have to ask ourselves, what values of x makes this inequality true, where x plus 5 is greater or equal to 0, and we have found our answer, x is greater or equal to negative 5. So as long as x is greater or equal to negative 5, our function is defined, and our domain here is going to be d is equal to x such that x belongs to all real values, but x has to be greater or equal to negative 5. Okay. So going back to our question, we're trying to find the function that has domain of x is greater or equal to -11. And we found it. Option A is our function. So this solution is correct. Good work. All right, moving on.